discrete versus continuous probability distributions. Types of variable. So we have qualitative variables, for example, the color of a student's hair. We have quantitative variables, and we can divide those into discrete and continuous variables. So discrete could be the number of students in the classroom, and a continuous variable could be the height or weight of a student. If we randomly select one classroom in a school and count the number of students in that classroom, then x, the random variable representing the number of students in that classroom, is referred to as a discrete random variable. We're counting the number of students, hence the discrete. We randomly selected the classroom, and from one classroom to the next the number of students can vary, a discrete random variable. We could randomly select a student from this classroom and measure the height of that student. The height would be a variable because it varies from one student to the next, and it's a continuous variable because height is something that we measure. It's on a continuous scale. X is a continuous random variable because height is measured on a continuous scale. We randomly selected a student, and the height would vary from one student to the next. So the graph here shows possible outcomes, which could be the number of students in a classroom and their associated probability. And we're looking at a bar chart. For continuous random variables, this curve is referred to as the probability density function. So you may be given an equation for it. The total area under the curve is equal to 1, and we calculate probability by calculating area under the curve. So we have a discrete probability distribution and we have a continuous probability distribution. So on these graphs we have the outcomes on the horizontal axis and something to do with probability on the vertical axis. So if our variable is discrete, it's actual probability, and if our variable is continuous, it's the value of the probability density function that goes on this axis. And the probability density function again is the equation of this curve.